head on towards the sun and start its science mission. So that's a very important burn to make sure we get out of the Earth orbit and on towards the sun.
And we can see in this animation here that there's subtle little firings there.
Yep, that's the RCS thrusters settling the vehicle and getting ready for that main engine start too.
All right, and so as we stand by for that, we're going to send it back to the ASOC. Joshua, we'll let you have it, and we'll continue to monitor the discussion here between the launch teams and the Centaur rocket in coast phase.
Thanks, guys. Appreciate that update. We are very excited. And as Solar Orbiter continues pressing on to spacecraft separation, let's take a closer look at what's ahead for this mighty explorer.
Ever since we've been pointing spacecraft at the sun, 2 regions on our star have been missing from satellite images. The sun's 2 poles have never been mapped because all the solar images we've built have remained in the ecliptic plane, the swath of space roughly aligned with the sun's equator, where all the planets orbit. A new mission from the European Space Agency and NASA called Solar Orbiter aims to escape this plane and take the very first images of the poles.
The planets are all moving and circling the sun, and so we already have some velocity going one way. If we want to launch up out of the ecliptic, it requires more energy.
To get outside the ecliptic plane, Solar Orbiter uses Earth's and Venus's gravity to slingshot itself into a view of the poles. The only other satellite to fly over the poles was Ulysses, which launched in 1990 to study the solar atmosphere. But Solar Orbiter will be the first mission to capture actual images of this hard-to-reach region. Scientists think the poles could be the missing piece to understanding what drives the sun's activity. Every 11 years, the sun's magnetic field flips. North becomes south and vice versa. This mysterious process has direct effects on Earth. Before the poles flip, solar activity reaches its peak. The number of eruptions increases, sending powerful bursts of solar material that can potentially harm our astronauts and satellites.
We don't really have a good understanding of the global solar behavior.
Another one of the mission's goals is to monitor how these eruptions and solar material travel through space. Using a suite of 10 instruments, Solar Orbiter observes an active region on the surface as it explodes, and then also takes measurements as the escaping material passes directly by the spacecraft.
Solar Orbiter will give us a comprehensive, full view of the entire sun and how the sun is impacting throughout the entire solar system.
At closest approach, Solar Orbiter will be closer to the sun than Mercury, at a mere distance of 26 million miles away, the ideal distance to get a comprehensive view of the sun and its surrounding atmosphere. It will fly close to the sun every 6 months and endure temperatures more than 900 degrees Fahrenheit. To survive the intense radiation, a large titanium shield protects the instruments, while a carefully orchestrated dance of opening and closing eye holes in the shield allows the instruments to peep out at the right time. Other instruments will directly measure solar material from behind the shadow of the shield. All of these observations will tell us more about the sun than we've ever known before. And by the end of the 7-year mission, we will have seen our star in a completely new way.
Our understanding of the sun will change dramatically. I will say that we are living in a revolutionary moment in our field.
So we'll get back to Solar Orbiter in just a minute, but right now I'm joined by Kennedy Space Center director, 4-time shuttle astronaut, space enthusiast, all-around good guy, second longest running center director actually now, coming up on the first and not too long, Bob Cabana.
Great to be here, Josh.
Hey, thanks for joining us. Appreciate you taking some time for us.
Another great launch by the ULA Atlas V and our launch services program here at the Kennedy Space Center.
So beautiful. So beautiful.
Oh, man. Awesome.
So I know that you love to kind of think big picture and talk big picture when it comes to the work that the Kennedy Space Center and NASA are doing. So how does the Solar Orbiter kind of fit in the big picture of what NASA is doing? How is this a part of our universe, so to speak?
Absolutely. So Solar Orbiter is on its way to study the sun, right? And one of the issues that we have is sending astronauts beyond our home planet. So with